Here in lesson 2.2, we are going to talk about exponential growth, and this is going to be part 1 of exponential growth. In lesson 2.3, we'll discuss the second part. In exponential growth, the population grows proportional to the size of the population. So as the population gets larger, the same percent growth will yield a larger numeric growth. So, for example, say you keep having a 5% growth, but if you had 100 people versus 150 people, 5% of those two numbers would be different. So that's why it's saying that we may have the same percentage growth, but we're going to have a larger numeric growth. If a quantity starts at a size that we're going to call p sub 0 and grows by r percent, and if you write as a decimal, you would use little r every time period. Then the quantity after n time periods can be determined using either relation. And like we had in the last lesson, we have both a recursive and an explicit form. Again, the recursive is handy if you know a previous term, but typically explicit form is more what we will use. So for the recursive form, we would do 1 plus our rate as a decimal times the amount that we had before, and that would be Pn. But again, if we don't know the previous amount, then we got to go this other route. So the explicit form would be p to the n equals p sub 0, which is your initial amount, times in parentheses 1 plus r, where that's your rate as a decimal, to the power of n, which is time, typically in years, but it will be whatever time period is discussed by the question. Because sometimes maybe it's every so many years, maybe it's every so many hours, something like that. But default is just that is your amount of timing. If you recall from your previous algebra classes, this equation is your exponential growth and is for a geometric sequence. All right. Example here. A friend is using the equation p sub n equals 4,600 times parentheses 1 plus 0.072 to the power of n to predict the annual tuition at a local college. She says the formula is based on years after 2010. What does this equation tell us? All right. So from this right here, p sub 0 is going to be that initial amount right in front, 4,600. Since this is years after 2010, that means in 2010, the tuition cost $4,600. Now, this does not look exactly like this, but what we could do is we could do 1 minus this number, and we could rewrite it in this form. And that's what I did here. I took the 1.072 and broke it into 1 plus 0.072. 0.072 is your little r, so you multiply it by 100 to get your big R, which means that this is really a rate of 72.2%. So, from this equation, we're able to tell that in 2010, the tuition cost $4,600. And based on this right here, we can tell the tuition is expected to rise 7.2% per year. Another thing also, now this does say exponential growth. If we're talking about exponential decay, then we would be going down, and this would be a minus instead. But we're talking about growth, so that's why it's a plus. And we have 4 more examples. Between 2007 and 2008, Olympia, Washington grew almost 3% to a population of 245,000 people. If this growth rate was to continue, what would be the population in 2014? So, n equals 0, that's going to be our initial year. And that's going to be the 2008 that they told us here. Because it's saying between 2007 and 2008 that we grew that much. So that means that in 2008, we'd experienced that kind of growth, and we have this population. So our p sub 0 is going to be our initial amount, which is the 245,000 people. Our rate is 3%. You divide that by 100 to get a little r of 0.03. We need to figure out how many years to be our n, our time. From 2014 to 2008, that is a total of 6 years. So we do p sub n, which is going to be 6, equals our initial amount, which is the 245,000 people, parentheses 1 plus our r, which is 0.03, to the power of n, which is 6 for our 6 years. 1 plus 0.03 is 1.03 to the power of 6 times 240,000 ends up being this gross decimal of 292,542.8126. Since this is an approximation, we'll go on ahead and just round accordingly. So we'll round this up and make it approximately 292,543 people.